I'm going to talk today about zero trust architecture, zero trust security. All of these things are just used throughout each other. I will explain what it is and give a few demos. And everything I will, explain for .NET 5 or .NET 6 or whatever. But first, you guys are coming out of a coffee break, so I want to challenge you guys. So please stand up for a moment for me. And just ask your neighbor, preferably the person who you do not know yet, where this number is about. Any guesses are fine. Just I just heard here, can you give us a hint? No, sorry. Because it was absolutely not about this number. I will explain in a second what it is, but it was about getting a little bit more energy in this room. And that worked. Actually, what happened just, if you stand up like this, your brain gets 60% more oxygen. So, you just had coffee and now you also have oxygen. Awesome. Go ahead, sit down, please. This number in the billions is the number from the accounts on Have I Been Pwned? Who knows this website, Have I Been Pwned? So if you don't know it, check it out, this website, and fill in your own email address and see how many times you have been part of a leakage on a data breach somewhere. Anybody guess this? There? Did you Google it? No, you knew it. Okay, cool. Okay, so that was just a starter. But, we wanted to keep it a little bit interactive. So can I have hands, please, for everybody who has production access over here? And you can keep them up for a moment, so please just keep them up. Because I have got a second question. Who of you guys can take down a production server or service without asking one of their direct colleagues? Well done, guys, well done. I would say no wonder 96% of the Dutch companies are struggling with the cost of cybersecurity. If it's so easy to take down a production site, how easy will it be, just to hack into one of your systems? And I will explain in a second why I'm saying that. This number is coming from a great report. You guys might have heard of the State of DevOps report, but there's also a cybersecurity report by Azure. You can just Google it. Also, if you look later on in my slides, you can find it. And there's a lot of interesting numbers about cybersecurity and the state of it at the moment. One of the most shocking ones is actually this one. For me, it is, at least. For 32% of the companies, security is not part of the cloud discussion. So that means that pretty much every company is moving to the cloud right now, and 1 out of 3 is not discussing security as part of it. And that's quite shocking, because now we're in the cloud, a lot of things are more accessible, and we will talk about that a bit more in a second. So who am I? I'm Alex de Groot. 35 years old. I'm consultant these days for software vendors. You can find me on Twitter if you have questions at Alex de Groot. This is officially my last engagement for Xperiod. So I'm still consultant at Xperiod, but that's only for another week. And I'm on vacation that week. So today is really my last gig. And it's great to be in front of you guys for that. What I'm going to talk about today is probably applies to everything you see here, to PHP, Java, etc. And I'm not sure if you guys know this icon. Rust, I here in front. If I knew Rust had such a cool icon, I would have used it a lot more. But it also applies to Rust, actually. So what is zero trust? Well, for sure, if you are climbing a mountain, then you probably know what zero trust is. You want to ensure things before you actually trust it. You will actually check your wire twice, and then you say, okay, I have trust. You need a little bit of self-confidence, but zero trust is really, and I will give you the principles in a second, is really about not trusting everything and always verifying. So where does this come from? This guy, Stephen Paul Marsh, and I actually don't know if this is really Stephen Paul Marsh, but I couldn't find a real picture of him on the internet, only on another presentation. So this is Stephen Paul Marsh. But Stephen Paul Marsh is a professor on the University of Ontario, and he in '93 wrote a paper about that the computer world is changing and that the attacks are coming from all of the different sides, so that we have to trust less. And it was kind of the first start. And then this guy came, John Kinderweg, and John Kinderweg was at that moment working at Forrester, and he saw actually that companies were struggling a lot with security. And around 2010, so that's 17 years later, he actually published in one of Gartner's or one of Forrester's reports. He published something about zero trust, and software is changing, hardware is changing, so we also need to do something about software, about security. At the same time, roughly, Google actually started to look at the world and said, something is really happening in the world. And it was about 2009, 2010, 2011, it wasn't really sure, that Google started to talk about Beyond Corp. Beyond Corp is the movement where we are all in. I promised not to talk too much about COVID, or not to talk about COVID, but we are in a Beyond Corp move. Everybody has worked at home and tried to access the systems he had in the office. That's Beyond Corp, beyond the corporate identity, beyond the corporate borders. And this is where Google was talking about, and all of these other guys were talking about. Basically, they are saying, well, you have something which is restricted on one side. You access it through the cloud or through the internet or whatever, from any device everywhere. And we used to have the idea that this part was secure. So if we look at today's websites, that's typically how we think about it, right? I mean, we visit the website, and that's inside a network, and that network is secure. Right? We deploy it there. We got a few network guys who make sure that there's a firewall and there's a reverse proxy and all of these tiny, kinky, cool stuff, thingies they do there, and then it's safe. And the truth is, it's not really true actually anymore, because you access the world from everywhere. And at the same time, you also might deploy something yourself. I will get back to that in a second. So it was 2018 when the US Department of Commerce added, they have this standard, the National Institute of Standards and Technology, and they added zero trust as part of a requirement for all of the US bodies. If you want to have infrastructure in the US these days in a special category, so if you're a ministry or if you're in defense or any of these things, you will have to adhere to these standards, the NIST SP 800-207, and zero trust is an integral part of that standard. This is a very important thing because this is pretty much the only governance standard when it comes to cybersecurity around the world. So once they publish it inside the NIST, it basically becomes reality. And yes, we have some standards in Europe. On the privacy side, they are way better than the US. But when it comes to the security part, the US is definitely front leader. So Zero Trust is really about something they call perimeter-less security. And that means that you no longer have a border around your house which you can trust. Because the guy who wants to do harm to your application might be on your computer. Or he might be on the computer of the guy next to you who you trust. So there is no such a thing as a perimeter anymore. The perimeter is just gone. And we used to think about it in this way, right? You know, we used to think about, okay, so we have the outside world, which is untrusted, which is public. Then we have a firewall, which is, you know, like our strong man, our army. And then we have our servers in a DMZ. That part is sort of halfway trusted. We know precisely who can access this, and we have some police, typically called IT infrastructure, who are actually defending this part with their entire, you know, army of rules and those sort of things. And then we have the inside part. Those are our laptops, and that through the firewall they are actually allowed to change everything in the DMZ. So I can update software there and all of that stuff. I can just, whatever, go ahead. Is this familiar to you guys? Who still has a network like this? I only see two guys. I don't believe that, actually. Because otherwise you guys wouldn't be here. So the world has changed. We are working everywhere, from Starbucks or from whatever terrace in the world. You know, that has changed. But also, but there's also, you know, the cloud movement, etc. I will get back to that in a second. So with this change of the world, we have a need for a new way of security. And this new way of security is called Zero Trust. And every cloud vendor out there has its own definition, but I pretty much like the Microsoft definition of it. And they have three base principles as part of Zero Trust. First one is verify explicitly. The second one is use privileged access, and the third one is assume breach. So why do I care about it, that you guys care about this? Because you guys are engineers, right? You know, you don't have anything to do with ops, right? A few of you guys actually had access to production, so you might do some ops. But with the cloud movement, you guys are becoming more and more responsible for the hardware and, you know, for all of the services and the servers and the VMs and the PaaS services and all of these things you guys are selecting. It's no longer IT ops who does that. And at the same time, you as a Scrum team, you know, or as a DevOps team, you make decisions about security. You decide to use SA as root password and, you know, that sort of stuff. You make those decisions now these days. And then, you know, in the world of containers, you know, you also make decisions about what is installed on these containers, what do you ship with it, etc. So basically, in this entire move, it's no longer IT ops who should care about, you know, security. It's you guys. And that's the reason why I'm talking about it. So I'm actually not going to talk today about all of the network aspects of Zero Trust, because you can talk to IT ops about that. Also, you can read the NIST report. They will explain that. And if you have a compliance officer, he can tell you precisely what you need to do to your network. I don't care about that part. That's the boring stuff anyway. And it doesn't help to get people out of your network. No, what I'm going to talk about is how you're really going to do assume breach and those sort of things. So this first principle, assume breach, what does that mean? Well, basically, you have to assume that the intruder is on your container. So he's logged in on your container. And he's there to do a query on the database and to sell it on the black market. You know, he's just gonna sell your data. That's his ID. And if he's not there, then he's on the other container and he tries to connect to you. So how are we gonna prevent this from happening, and how are we gonna deal with that? Well, the first thing is that we're actually gonna avoid that this intruder, if he's logged in onto your container, that he can do something. So what are we gonna do? We're gonna look at the containers. How can we minimize these containers? Let's have a little bit of a look of code. You guys have seen the different demonstrations by Scott Hunter and all of the other Microsoft chaps. It's always fun with demos. If you have like a default or a start new project like this, then then it looks these days with the ASP.NET Core. It looks like this. You have what do you have? You have a builder, and then you do some HTTPS, and then you take you make an endpoint here, and you do some cool stuff there, and then you return something. Really cool. And also as part of that, if you put on the the checkbox to say, hey, I want to Dockerize it, it will automatically create this file. And this file actually does the following thing. What it first does is that it actually sort of downloads the ASP.NET image, in this case version 7, and exposes a few things. And that's actually interesting because they help you a little bit, and they basically say, well, you can only connect to this container on port 80 and 442, so that's 43. That's actually quite good. So this one is for the unencrypted traffic, and this is for the TLS traffic. And then they actually download another container. They do some builds with it. Then they take the same container again, and then they do a publish with it. And finally, they take this base container, as you can see here, the base container, and they publish the information basically from the final. They publish it into, or from the publish, they publish that into this final container, and then they start things up. And what is interesting about this is that they actually take here a standard Microsoft container, which is quite bloated actually, if you look at that. I think if you look at this container, I might be able to search it up in my local containers here, in my local images. I think this thing is, of course, this is like it's like 200 megabytes, and you're like, hey, all I want to do is run .NET and run this DLL. Why is this 200 megabytes? Well, that's because they actually put in an entire Linux kernel in it. And what does that mean? SSH and a lot of other crap, and people can actually connect to this container. Luckily, also Microsoft has noticed this, and that this is probably not a good idea. They still supply this as the standard template, but fine enough. They have started to move away from it. They started to create base images which are only containing the small pieces which are really in the need to be there. Let me show that. Actually, and I'm just going to show the website of a guy who has actually done all of the research about this. Here you see a list of all of his experiments he has done. And what he has done, if we take, for example, .NET 6 here, he has taken, like a standard image, and put a website on it, and then the standard image is 208 megabytes. And then he looked further. If you take, if you build the .NET application and you make it self-contained and you base it on the runtime dependencies image, then you chew off like 75%. So how does that work? And you can actually go further. There's actually one here, number 14 with .NET 7. It's self-contained, it's trimmed. So I will show you guys in a second what that means. And then only basing itself on the runtime dependencies, then the container itself is only 40 megabytes. That's awesome. Really, that's awesome, because that means that there's only 20% left. So there's no crap in it anymore. Let's have a look at this, what they do to do that. Here we go. We just go. This guy, it's actually an Australian guy. He just put it on GitHub, and you can just download it there. It's really cool. What they do is actually they do the same thing with this base image, but they have here the .NET runtime dependencies. This is the base thing they take. Then they clean up stuff, even out of that. So Microsoft has delivered an image and they clean it up even further. And then they still use the SDK to build things. Do the regular things like like restoring and publishing, and there's probably build is probably a part of it. And then they create a final container from scratch. That basically means a file system with nothing on it. They put a little bit of libraries on it. They need some libraries, some runtime libraries, and they need some certificates on it. And they need this thing from Google, the distroless temp.tar. So they sort of copy over that thing. Set 3 environment variables, like startup on port 80, run in a container, and don't do globalization. That's kind of what they do. And then they put it in, the files finally in it, and they start the application. In the end of the story, you have a working application, a .NET application. Remember the time when you did the full framework and when you had this binary of XCE of 400 megabytes, basically nothing in it. Now you have a full-time running thing of 40 megabytes. There is no way how an intruder can get on a thing. So you have now an application which is only running on that small thingy. I'm not going to do the demo with the building of the image because that only will go wrong. I'm just going to quickly go back to my slide deck. If you are then, okay, now I've dimmed down my container and you're like, I'm good. No, you're not. Because there's one thing still possible, and you can actually put some stuff on that file system. And if you are working on AKS, for example, Kubernetes, you can actually do something. If you do this is a pod, you can actually make your container, your file system read-only as well. And that means that even if they somehow find a way to get onto that container, or they somehow find a way how to put files on it, you have just disabled it. That's, again, impossible. Really good. You're doing an awesome job. Actually, you do something better than your system ops has ever done. Cool. So then you can do another thing, and that is actually say, okay, if they are on my container, they probably don't want to do something with my application, but they probably want to do something with my neighbor, application, or they sort of want to identify if they are me. So what you can do is you can very typically also, if you're in a Kubernetes cluster, you can actually say, I'm going to restrict the outside calls to the other places. So I can, for example, restrict that I can call Google again from my container. If you are an AKS, typically you can actually control this if there's an egress there. The new Azure Container Apps doesn't have this functionality yet. But since Microsoft is talking a lot about Zero Trust these days, please do me a favor and just vote on this GitHub request, because then we can also, with container apps, put something in front of it and make sure that outbound requests are also there blocked by it. So that means that there's basically impossible to get out of that container or to do something with it. Now, let's assume you have done all these things and there is still a possibility, for some reason that they have manipulated something, or you have an upload functionality so you cannot make your container read-only. Then it's quite nice to actually know what software is precisely on your container. And luckily, even for that, these days there's tools. There is this thing called SBOM, and I think there's another talk right now ongoing in one of the other rooms, which is about this. So hopefully it's recorded as well, and you can look at it back. But what we can do is we can take a piece of software, and we can actually get a report out of that. I think I had it here. Yes, there we go. And there's just a very simple, I'm just executing a script now. Let me show you what this thing does. Here's the script. This script does nothing more than .NET and then invoke cyclone DX. And then I just give my CS proy and then tell it to go to the output SBOM. And then you can actually, then it generates this file. And I need to format this thing, obviously, like that. And this file will actually contain a reference, will actually show like, this is what is inside my project. So it will make an abstraction of all of that, will show what licenses in there and what SHA is there from your NuGet packages and all of these sort of things. And this is sort of important because if you ever have, like a container where you're like, I'm assuming that somebody has changed some files in it, and at least I can check it against my container, or I can check it against this SBOM and actually verify if I build the same container again, if there's a difference in it. So that's another tool. This tool which I was using here is just a global.NET tool, so you can just do .NET install CycloneDX and you will get this here. This report, by the way, will also make your compliance officer very happy. I don't know why, but they generally like these sort of things. So, if you just generate it as part of your build, you're good to go. Cool. So that was the first one. Then verify explicitly. This is a lot easier. First of all, false. False is typically one of these things. If you serve files, even if you serve static content from ASP.NET, let me look at that. How do you do that these days? We have files here, like that. That's extremely simple these days because what you just do is this. You just say, hey, just use static files. But you can actually verify that even more explicitly because what Microsoft by default does is actually they serve everything what is in your www root. And they are just fine with that. So they just say, okay, there's 400 known file types and we just serve everything. Is that a good idea? Well, probably not because you are a developer and you know what sort of files are actually in this in this application. So you can restrict this list even further down. And what you can do is you can actually set up a content type provider and you can remove from this list. You can basically remove everything if you want to. So then it will not serve anything. But you can also say, well, I actually explicitly don't want to serve JavaScript files. There shouldn't be any JavaScript files. If that's the case, I can actually show you that. This is a demo which should work. So far it's doing something. This is always fun, right? Live demos. It's starting, it's doing something there. Yeah, cool. So what we can see, okay, so here we have this thing. So what we can see here is that there is a CSS file. So we can probably get there. So we can just do css.site.css. Yes, that's working. And now we also had /js/site.js. Oh, and it blocks it. And this is precisely the intention as well. Why is this so important? Especially if you create upload functionality and those sort of things. It's really a good idea to actually just minimize the amount of, the sort of file types and those sort of things you expose there. And this is really part of a very simple thing of, just verify everything. And along the same lines, I have a very simple demo here as well, which is a very simple endpoint, which is called my int endpoint. And what my int endpoint basically just shows back an integer. Really advanced. So if I do that, I hope you guys can see this in the back. Basically, so it's just going to give. It just gives back this, and I can also do a minus. This is really fun. You can just do a minus. But this is another one of those things where quickly things go wrong. And it seems that in the .NET space, we sort of forgot about the concept which is called uint. It's a very simple thing, an unsigned int, which basically means that it has to be positive. So on the category of verify all things, extremely simple, but if we go back there and if it starts, and it does, wow, 2 demos. Come on, you can do this. Yeah, okay, so here's the second one. So if I just do now int/-120 or -23, I actually get an unhandled exception. And because I'm a developer, it's saying like, hey, this doesn't work. And it will actually work if it's positive. This is another way, a very simple way of you guys just to verify everything. Why do I point at this one? How many times have you guys built actually a route like this, where you sort of always assume that this integer, which is in the database, is always positive, but you actually allowed negatives. And for some reason, this actually ended up being in the OWASP 20 in this case. Okay, so that was verify everything on that part. Then there's another thing. So you are working with your coworkers and together on this awesome project, and you guys have authentication arranged, you have dimmed down your container, etc. And then this only guy, he forgot about adding authentication to his controller. Ha! Sorry, that endpoint is open. It does happen. It does. Really, no shame. So we can actually fix that right now in a lot cleaner way. If you look at this one. In the latest version of ASP.NET, and I'm not sure if this is actually working in 6, but this is working in 6 and also in 7. But what you can actually do is, if you add authorization, you can sort of add a fallback policy. And that means that if it's not specified, the request will always need to be authorized. So that means that people don't have to do this, like require authorization over here. It will just always fall back to an authorization request. It's a simple thing, right? But it's a very neat feature. Okay, I'm not going to get you guys into configuring authorization. We saw Scott Hunter. That's way too complicated at the current moment for the human mind, so we would just wait for .NET 7 or 8 when they release that part. Then there is this picture. And I'm just not sure if everybody recognizes this picture, but this is the sort of traditional authentication flow these days. If you're using OAuth, so you're a client application, you're probably a browser, and you use that browser just to get from an Active Directory to get a token. You get that token back all the way. Then you take that token together in your header and you send it to your web API, and then your web API sends back a response. Wrong. One of the problems with this is that you sort of assume, and you probably have a good reason to assume, but you once more assume that this token is right. So if you implement a zero trust architecture, you want to verify that. And that means that after 1, 2, and 3, when you are here on the server, you will actually do a call to the AD and verify if that token is valid, and before you actually answer it. Now, a lot of people are going to say, well, is that really a good idea, Alex? Because what about my reliability? Because what if the Azure AD is down? And yes, that happens. I understand that. Well, there are actually possibilities where you can, for example, fetch a certificate from the Azure AD, and you can actually use that to verify if that token is well encrypted. And then you sort of know for sure that that token is there. But once more, you have to verify that token is well encrypted. Now, please, 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 don't. If you take that token, and if you decide to go through that route, and you decide to say, okay, I really want to have that token, I want to verify, I want to have that certificate to verify my token, please don't take a token for the next of the year, or download that token and for the next of the year. Please make sure that you download it again next hour. Because that means that if there's a breach and somebody has stolen the token, he's only able to be there the next hour, to use that token the next hour. Or preferably, because 1 hour is quite long, why wouldn't you download that certificate every 5 minutes, for example? That's just possible. We're in cloud technology, it doesn't cost anything to download that certificate again. Okay, so that was verify everything. Oh, I'm even on schedule. Wow. Then the last part, used least privileged access. And then, you guys are all able to access to production. Who of you guys is actually using multi-factor authentication at the moment that he's accessing production? I'm so happy to see this. But I still was a little bit scared about the response on my second question. And I want to challenge all of you. And it doesn't really matter if you're on Azure, if you're on Google, on Alibaba, or on AWS. Please start to use a technology which allows you to get just-in-time access, with preferably a coworker which approves that. And that means as much as I probably don't have access to my production environment, but at the moment that I need it, I request it, and a coworker approves it. And there will be a lot of people talking about, yeah, that's hard to implement. Well, actually, in Azure AD, it's not hard to implement. There's a thing which is called privileged identity management that costs, because you guys probably also already have a 365 account, that costs €12 a month. Do you know what a security breach costs? Up to 10% of the monthly or of the yearly revenue of a company. Make the math. Moving onwards. Oh yeah, and then this thing. I don't want to offend everybody, but please get rid of the God accounts. So that includes the database God accounts. It's quite a good idea. Preferably if you are actually talking to another resource. So for example, you're talking with your client app to a web API, and you're then onwards talking to a database or to another web API, you could actually avoid using things like managed identities or God accounts or anything like that. You could actually talk on behalf of this user to this resource. There's something called, which is the on behalf of flow. It's part of the official specification of OAuth 2, and it will actually allow you to do something like this. You will get your token in basically with step 2, and then you will request to the Azure AD, you will request a new token which you can use for the request to here. And now out of a sudden, if this is a database, for example, you can use row-level security on this one. So that's awesome. You can actually have your user all the way authenticated. I really thought about making a demo out of this, and there's going to be one day when I will do this. But this is at the current moment so bloody hard to do, just to be honest, that I decided not to do it. But promise me, if I'm here back in 2 years, this is all I promise you, this is all integrated in the .NET framework. I will send an email to Scott about that later today. Hopefully he responds. So, just to summarize my entire talk, we're talking really about avoiding risk in this case. We sort of want to really avoid that we're getting into this point where potentially our application is vulnerable, and if we are there, then we sort of want to make sure that the blast radius, so what they can do with my application, is a lot smaller. And you do that by taking these 3 steps. Verify everything explicitly. That starts with the smallest int to uint, but it also starts with reducing the files you allow for opening. But also that means, input validation, guys. I know it's horrible to write, but actually in ASP.NET Core 6, they have done quite a nice job to do it. Use least privileged access so that they cannot misuse your account. And assume breach. Assume that this intruder is on your container. Thank you for attending, and if there are questions, shoot.